All right, we're going to start reviewing for your Conceptual Unit 2A test. Number 1, it says write an equation for the linear function f satisfying the given conditions, and then graph y equals f of x. It's telling you that f of 1 equals 5, which gives me an ordered pair 1, 5. And it's telling you that f of 3 equals 6, which gives me an ordered pair 3, 6. To write an equation for the linear function, they're looking for y equals mx plus b. So if I can figure out m and b, I can write an equation. Well, to find a slope, it's y2 minus y1 over x2 minus x1. So my slope is going to be 6 minus 5 over 3 minus 1. x1, y1, x2, y2. That's going to be 1 over 2. So my slope is going to be 1/2. To figure out a b now, I can take either one of these ordered pairs. I'm going to pick this one, so I'm going to pick that x, that y, and my slope, and I'm going to change the y, the m, and the x so that I can solve it for b. So I substitute 5 for y, 1/2 for m, 1 for x plus b. And then I solve. That's 1/2, so 5 equals 1/2 plus b. Subtract a half, subtract a half. b equals 4.5, which is 4.5, which is 4 times 2 is 8 plus 1 is 9 over 2. So b is 9 over 2. Now, if I go back and I plug in my m and my b, I will have my linear equation, which will be y equals 1/2 x plus 9/2. Now, to graph that, you would start at 4.5. They're counting by 2's, it looks like, so 2, 4, that's 6, so 4.5, and then they go up 1 and over 2. So that would be my graph. I mean, a little better here. 1, 2, 3, 4, 5. You'd start at 4.5, go up 1 over 2, about right there, and that'd be that line. Okay. All right. Number 2, it says determine whether the function is a polynomial function. If it is a polynomial function, then state the degree and the leading coefficient. You have a polynomial function as long as you don't have negative exponents. You can't have letters and denominators, because those are negative exponents. You can't have fractional exponent. No, yeah, you can. So yes, the polynomial is a function. The degree is the highest degree or the highest exponent, and the leading coefficient is the coefficient touching the letter with the highest degree. So my leading coefficient is 5. Okay, it says describe how to transform the graph of mother function of parabolas into this function and sketch the graph. Well, the 1/2, anything outside is a vertical move. So that's going to be the 1/2 is going to be a vertical something. If it's multiplication, it's a stretch or shrink. This is multiplying by 1/2, which is going to shrink it. So it's going to be a vertical shrink of 1/2. The -3 on the inside, anything on the inside starts with the word horizontal. And if it's adding or subtracting, it's a shift. But this horizontal shift, because it's with x, is going to be backwards. So the horizontal shift is actually going to be to the right, not to the left. And then the -5, anything on the outside, again, starts with the word vertical. So that -5 is going to be a vertical something. It's addition or subtraction, so it's a shift. And outside is normal, so that's going negative means down. Okay, so vertically shrinks by 1/2, translates 5 units down, and 3 to the right. Okay, so if I choose the correct function, you're going to pick up the parabola, you're going to go 3 units right and 5 units down, which puts the vertex right there. And it's going to be a vertical shrink, which is going to make it a bit wider, because they're shrinking it from top to bottom, which is going to make it look wider. Alright, find the vertex and the axis. When you have a parabola in what we call vertex form, your vertex is at h comma k. Your axis of symmetry is at x equals h. So in my particular problem, my h equals positive 2 because it's backwards, and my k equals 9. So my vertex is at h comma k, and my axis of symmetry is x equals whatever h is. Okay, find the vertex and axis of the graph of the function. Rewrite the equation for the function in vertex form. Well, they're giving it to me in standard form, except for that's not even right because it's not in decreasing order, so it should be negative x squared plus 12x plus 7. And that tells me that a equals negative 1, b equals 12, c equals 7. I'm supposed to get this thing in vertex form, which is a parentheses x minus h squared plus k. Well, I know a. A is a. I don't care what form you're in. Okay, a is negative 1 here, so negative 1 is going to go there. Now, my job is I've got to figure out what h and k are. Well, we have formulas for that. If you are in standard form, to find your h, it's the opposite of b over 2a, and k, c minus ah squared. So, to find my h, I'm going to have the opposite of b over 2 times a. That's going to be negative 12 divided by negative 2, so h equals 6. To find my k, I'm going to take my c, which is 7, minus my a, which is negative 1, times my h squared. You square first, that's 36, times a negative is negative 36, minus the negative turns it positive, add, and you get 43. Okay, so there's my k, there's my h, there's my a, plug them in, oops, not x. Alright, and in vertex form, I'm going to have y equals negative 1 parentheses x minus 6 squared plus k. So that's where this came from. They just didn't write the 1, they just wrote the negative. And then if you want your axis of symmetry, it's x equals h, and my h is 6, so x equals 6 is the axis of the graph. And the vertex is h comma k, and there's your 643. Okay? And if you look at the picture of it, you can see at x equals positive 6, there's your imaginary vertical line. The maximum, because this is a parabola upside down, is at 643, which is your vertex. Alright, it says write the quadratic function in the form a parentheses x minus h squared plus k, find its vertex and axis of symmetry, determine if there is a maximum or minimum value, and find that value. Alright, they want me to complete the square. So what we do is we take our function, and I'm going to put this on the other side, so that's going to equal negative 21. Now, to complete the square, let me write that a little bigger, sorry. So x squared minus 8x, I'm going to leave some room and move the 21 over. Now, to complete the square, you add half of b squared to both sides. So to figure out what that is, I take my b, which is 8. I know it's negative, but once we square it, it's going to be positive, so it doesn't matter. Then I take half of that, which would be 4. Then I square that, which would be 4 squared, which would be 16. So what I'm going to do is add 16 to both sides, and that will complete my square. Okay, so to get it in vertex form, I go ahead and I complete the square. This is going to factor into a perfect square. The square root of x squared is x, the sign in the middle is minus, and the square root of 16 is 4. This side, you just add or subtract, and that's going to give me negative 5. Okay, so now move this back to the other side. So add 5, add 5. That gives me x minus 4 squared plus 5 equals 0. Now I'm in vertex form. There's my h, there's my k. So there's completing the square. Then the vertex is going to be 4, 5. The axis of symmetry is x equals h, so x equals 4. And it says the maximum or the minimum value. Again, if you graph this thing, your vertex is, if it's opening up, it's the lowest point, the minimum. If it's opening upside down, then it's the maximum. This one is going to have a minimum value, and it's 5. You always take the y-coordinate of the vertex. Okay? Alright, it says write an equation for the parabola shown using the vertex, which is hk, and any other point on the graph that passes through the graph, or that the graph passes through, but not the vertex. So what we have to do to write an equation is we need to know 3 things. I need to know a, I need to know h, and I need to know k. Well, I know h, and I know k. The only thing I don't know is a. So what we do is, the first time around, we're going to take our generic form and we're going to plug in a y, an x, an h, and a k. Because algebra works, I can figure out a if I know all the other letters. Well, I do. I mean, the x and the y can be any point that this parabola passes through. Okay, so, get my pen back here. I'm going to use this y, and this x, and this h, and this k, and I'm going to plug them in. So I have 18 equals a, parentheses, 2 minus a negative 1 squared, minus 9. This turns positive. That gives me a times, this is going to be 3. That's going to give me a times 9 minus 9. Now if I solve this thing for a, I'm going to add 9. And I get 27 equals 9a. Divide by 9. And a equals 3. So now that I know an a, an h, and a k, I'm going to plug those 3 in to get my actual equation. So it's going to be y equals 3 parentheses x minus a negative 1 squared minus 9. The double negative turns positive, which is why they wrote x plus 1 squared. Okay? Alright. A market sells cans of soda pop in machines. It finds that sales average 27,000 cans per month when the cans sell for 40 cents each. So right now, if you're writing a revenue function, right now you're selling 27,000 cans at 40 cents a piece. So if I were to try and figure out what my profit is, I would take 27,000 times 0.40, and that would tell me how much money I'm going to make. Okay? But it says for each nickel increase in the price, the sales per month drop by 1,000 cans. So what they're expecting to happen is they're going to drop this by 5 cents. I don't know how many times. They're going to keep doing it until they maximize their profit. But every time they do this, they expect this number, the 27,000, to drop by 1,000 cans each time we drop the price by a nickel. So there's where I've got my revenue function from. Okay. Now, if we graph this, and again, you would, if you were going to do this by hand, you would have to FOIL that all out and get a polynomial function. But you can just go to y equals and type this in next to y1, which is what I did down here, and then I hit graph. Okay, and I picked there, it said all their windows were this by this, so I chose the same window. No, I didn't. I chose it because I wanted to see a little bit over here. I don't remember what my window was, but it was close to this. Alright, so if you look, that's going to be this graph. Okay, now, what should the market charge to maximize this function? Well, if you find the maximum, in other words, the vertex of this, you get this. I calculated it on the calculator, and the maximum says it's 9.5, comma, 15312.50. Okay? This means we should raise the price 9.5 times. If we raise the price 9.5 times, okay, that's going to maximize my profit. So they're telling me that this will be my X. But what does that mean my cans should, or what should I charge for each can? Well, right now I'm charging 40 cents, but I'm going to increase that 9.5 times. I'm going to increase that by a nickel, which is 5 cents, but I'm going to do that 9.5 times. Okay? So, to figure out how much I should charge for a can, I take 0.40 plus 0.05 times 9. And it says that I should have 85 cents. Why am I getting 88 cents? Okay, give me just a second here. Okay, sorry about that. It would help if I typed it in the calculator right. Okay, so we are going to raise the price 9.5 times. Okay, so we were charging 40 cents. If I type this in, okay, if I do 0.40 plus 0.05 times 9.5, I get 87.875, which if I round that to money, that's 88 cents a can. Okay, and if I do that, the maximum revenue is going to be that y coordinate. And I'm sorry, back up here, this should be a plus. I'm increasing the price by a nickel, not decreasing it. So that one should be plus, but this one is minus because the cans are going down by 1,000 each time. So that would be my maximum profit. As compared to before, I mean, before I raised the price 9.5 times, my profit would have been the 27,000 cans times 40 cents, which was $10,800. And now my revenue is going to be $15,313. So by increasing the price to 88 cents a can, it's going to make people mad. I'm going to sell less cans, but I'm going to max out. Now if I raised it any more than that number of times, then my revenue is going to start going down because people aren't going to pay that much money for it. Okay? Alright, so it says determine whether the function is a power function. If the function is a power function, state the power and constant of variation. The power function looks like y equals, I don't remember what letters they used, ax to the b, whatever, okay? But the thing of it is this has to be the variable, this has to be a number, and this has to be a number, okay? So this is not a power function because my power has to be a number, not a letter. The statement is a power function equation. It says the area A of a circle varies directly as the square of the radius. If they say directly, that means A and whatever it's varying with. I mean, if you look at it as fractions, what that means is whatever they're varying directly, they both have to be in the same position in their fractions. Okay, so they're both on top, which means I don't need the fractions. And then again, don't forget you always have some constant of variation, which is why they're getting the k. Alright, match the equation to one of the curves in the graph. You can absolutely just type it in the graphing calculator and figure it out from there. However, what they're trying to get you to see is in the power functions, what you know is if, oh, that was a k, I think they called it. If that k is positive, yeah, they do call it k. If k is positive, okay, then you are going to be in quadrant 1. If k is negative, you're going to be in quadrant 4. So since my k is positive, I'm in quadrant 1, not quadrant 4. Okay, then if you look at your a, which is your exponent, okay, my exponent is 1/4. that is between 0 and 1. So my exponent is between 0 and 1, which means I am looking at the a is between 0 and 1. So I'm looking at this function right here. Okay, so it's going to curve like this, not like this. Okay, so it's got to be the red one, because I know it's going to curve like this and not like that. Okay, alright, and if I type it in the graphing calculator, my window's different than theirs, which is why mine doesn't look so steep as theirs does. Okay, there we go. Alright, so again, K is positive, so we're in quadrant 1. This is between 0 and 1, so it curves like this, not like this. So it's got to be, again, the red one. And again, if I graph it, you can see. Alright, it says state the values of the constants K and A for, there's your letters, f of x equals k times x to the a, and answer each question about the function and its graph. Okay, 3x to the negative second. That means my k is 3 and my a is negative 2. Okay, pretty easy. The graph, this tells me that I'm going to be in, k is positive, so I'm going to be in quadrant 1. A is negative, which tells me it's going to be the asymptotic one, this one. When A is negative, you get that boomerang one, the one that's asymptotic, so it tells me it's going to be like this. Okay, and that is this one. Oh, and it's because it's got to also pass through 1 comma k, so it's got to pass through 1 comma 3, and this one doesn't. Okay, what else do they want to know? What is the function? Well, you have to look at, if it's an even function, that means that the y-axis will cut it exactly in half. So if you look at the other quadrants 2 and 3 over here, you will see that it does reflect over y, which makes it an even function. Okay, and again, if I typed it in my calculator, you can see both sides and you know that it's an even function. Okay, the volume of a gas V held at a constant temperature in a closed container varies inversely with its pressure P. If I write a power function for that, V varies inversely with P. So V is on top, P is on bottom, and then you have some constant of variation. Okay, and it says, if the volume of gas is 600 cubic centimeters when the pressure is 250 millimeters of mercury, find the volume when the pressure is 300 millimeters of mercury. Okay, well, the question is find the volume, okay, when the pressure is 300. Well, there's my equation. I just need to solve it. The problem is, the problem is you can't solve algebra when you don't know 2 of the variables. You've got to know all but 1. That's why they're giving me, this is the question I need to answer, but I can't answer it until I figure out what K is. So to figure out what K is, that's why they gave me this. They gave me both the volume and the pressure that I could plug in so that I could figure out in this situation what my constant of variation is. So I'm going to plug in 600 for volume and 250 for pressure and solve it for K. So I would have, volume is 600 equals K over 250. So to solve for K, I'm going to multiply by 250, and K equals 250 times 600, 150,000. So now I can plug my K in here and solve it. So I have volume equals 150,000 divided by 300, and my volume is 500 cubic centimeters. Okay. Graph the polynomial function and locate its extrema and zeros. you can, I mean, obviously type it in the graphing calculator, which is what we're going to do, but what they want you, if you were just having to pick a graph and you couldn't type it in a graphing calculator yourself, they want you to, kind of look at a couple things. First of all, it's an even function, so the tails have to point in the same direction, which they all do. The leading coefficient is negative, which means that the tails have to point down, so those two are out. Okay, and then you can look for your y-intercept, which if your polynomial is written in standard form, your y-intercept is going to be at the constant, which in this case would be 0. Well, they both pass through 0, 0, so I'm down to those two. So if we type it in the graphing calculator, there's my picture. Okay, so I know that it is this one and not that one. Then it says, select the correct choice below, and if necessary, fill in the answer boxes to complete your choice. It says the local maximum is and the local minimum is. Well, your maximum is going to be at the highest point that you can get. So I did second calculate, and I calculated a maximum, which is at 1, 3. Okay, and there is no local minimum because these go down forever and ever and ever. You can't ever get to the bottom. And then the zeros of my function are, again, if you calculate your 0, left bound, right bound, and then calculate this one, left bound, right bound, yes, you get 0.00, because it says rounded 2 decimal places. That's why they really have to put 0.00. And here, if I rounded 2 decimal places, the 7 bumps up the 8, so it's 1.59. Okay? Use the leading term test and your knowledge of y-intercepts to match the function with one of the graphs. Again, you could totally just type it in the graphing calculator, but you wouldn't need to on this one. It's a 5th degree function, which means your tails have to point opposite directions. Your leading coefficient is positive, which says that the second tail has to point up. So however this wiggles in the middle, this tail has to point down, and this tail has to point up. So that's out, and that's out. The only one that works is B. This would have to be an even function because the tails are pointing the same direction. Okay? So we chose that correct graph. Also, I can tell that it's supposed to cross at +7. And again, they're counting by, they're going from -50 to 50 on the y, counting by 10, so that first mark is at 10, which right underneath it would be about 7. Okay? And again, I traced that so you could see it really is crossing the 7. Alright, it says describe the end behavior of the polynomial function using limit notation. Well, again, they don't want you to type it in and get a picture yourself. They want you to see what the tails are going to do. This is a 3rd degree function, so the tails have to point opposite directions. The leading coefficient is 1, which is positive, so the second tail has to point up. So first tail is going to point down, wiggle in the middle, second tail has to point up. If we describe, they want us to describe as x is going to infinity first, that's this one. So if you could draw an axis on here, it doesn't really matter where it's at, but as you pick bigger and bigger x's, what's happening to the y values? Well, all you have to do is look at the way the tail's pointing. It's pointing up, which tells me that the limit as x approaches infinity, in other words, as I look towards the right, this tail points up, which says that my function is going to go to infinity. If I describe the other direction, as I go this way and I pick smaller and smaller and smaller x's, what is the y values doing? We'll look at where the tail is pointing. The limit as x approaches negative infinity, the function, the y values are going to negative infinity. Okay? Alright, so there's the actual graph. Okay? Alright, it says graph the polynomial function, approximate all of the real zeros of the function. Alright, it's a 3rd degree function, which means the tails have to point opposite directions. They all do, so I can't eliminate any there. I know that the second tail has to point up because my leading coefficient is positive, so that one's out, and that one's out. So now it's down to those two. This tells me that it needs to cross the y-axis at positive 63. Well, this one's crossing at a negative, so it's got to be this one because it's crossing the y-axis at a positive. Okay, and then if I approximate the zeros, you type it in a calculator. Alright, I've got 1 0 at negative 3.5. You see this, you get a y, you get an x-intercept when y is 0. This 3e negative 11 means 0.0000000, 10 zeros and a 3, which for all intents and purposes is 0. So I've got 1 0 at negative 3.5, I've got 1 at 1, and I've got 1 at 1.8. Okay? Alright, and then it says find the zeros of the polynomial function and state the multiplicity of each. Alright, they're giving us a function in factored form. Well, if you set it to 0 and we use the zero product property, that says x plus 3 squared equals 0 and x minus 1 equals 0. This, whatever this zero, this is a factor, whatever the 0 comes out to be is going to have a multiplicity of 2. Okay, because of the exponent. Now, because it has a multiplicity of 2, well, they're not asking what's going to happen yet. But again, remember, this means that it's going to just touch and turn. It's not going to cross through. This one, if I add 1, or when I get through solving it, it's going to have a multiplicity of 1. Because its exponent is a 1. That's an odd multiplicity, which means it's going to pass through. But to figure out what the zeros are, you set it to 0 and solve. So to solve the first one, square root, I get x plus 3 equals 0, minus 3, x equals negative 3. Add 1, I get x equals 1. So the zeros are 1 and negative 3, doesn't matter what order you put them in. Negative 3 has a multiplicity of 2, and 1 has a multiplicity of 1. And if you can see, here at negative 3, it just touches and turns, it doesn't pass through, but at 1, it crosses all the way through and keeps going. Okay, it says using only algebra, find a cubic function with the given zeros. Support by graphing your answer. They're telling me that x equals the square root of 2, x equals a negative square root of 2, and x equals 5. We're basically starting at the end. We have the answers, and we need to back it up until we get to the function before it was factored and then eventually solved. So to do that, we're going to turn my zeros back into factors, which means get 0 back on the right. So minus the square root of 2 minus the square root of 2. That gives me x minus the square root of 2 equals 0. Add the square root of 2, add the square root of 2. That gives me a factor x plus the square root of 2. Minus 5 gives me x minus 5. Set it equal to 0. And you'd be done. That would be my function. But they want it in standard form. So 2 at a time. I'm just going to take these two and I'm going to FOIL them out. X times x is x squared. That's going to be a positive x square roots of 2. That's going to be a negative x square roots of 2. And that's going to be a negative square root of 4. If I clean this up, these cancel each other out. And that turns into 2. So I end up with x squared minus 2. So don't forget, times the x minus 5. So if I FOIL that out, x squared times x is x cubed. Minus 5x squared minus 2x plus 10 equals 0. And that's my function. F of x equals x cubed minus 5x squared minus 2x plus 10. Okay? The State Highway Patrol Safety Division collected the data on stopping distances given below. Answer the questions going through A to E. A says, draw a scatter plot of the data and choose the correct graph. Okay, so I went to Stat, and I put these in under L1, I put these in under L2, set my window. I think I set my X window to go from 0 to maybe 55, 60, and I think I set my y window to go from, looks like maybe -5 to maybe 170. Okay, and then remember in the Y1 screen, you got to make sure that your plot 1 is on. Make sure it's flashing black. And I get my scatter plot. Okay, and then it says find the quadratic regression model. So you go back to stat and you choose quadratic regression, and there it is, and they give you A, B, and C. So if I round it, I get y equals 0.055, the 8 bumps the 4 up, x squared, plus 0.461, the 5 bumped up the 0, x plus 11.02. And then it says superimpose the regression curve on the scatter plot. Well, that just means that it's going to, if you go back to y equals and you type this in next to y equals and hit graph again, it will draw the line through there. Okay, and then it says use the regression model found in part B to predict the stopping distance for a vehicle traveling at 25 miles an hour. Well, your x was your speed, right? So we're going to change x to 25. So I'd have y equals 0.055 times 25 squared plus 0.461 times 25 plus 11.02. Type it in the calculator and you should get 56.92. Okay. Alright. Divide f of w by d of w and write the summary statement in polynomial form. F of w, those are our robbers. -4w cubed plus 6w squared minus 7 divided by w minus 3. Okay, if we do long division, we could actually do synthetic here if we wanted to, because I'm dividing by a binomial with leading coefficient 1. But remember, we take the leader of the gang and the lead detective, and they go to the alley and they divide out a deal, which gives them -4w squared. That's the secret knock to get in. So they all have to do the secret knock. -4w squared times w is -4w cubed. -4w squared times -3 is positive 3w squared. Draw the line and change the signs. Pull your guns out. If the third degrees cancel, combine like terms. I have 6w squared minus 3w squared is 3w squared. Wait a second, that's not 3, that's 12. Silly goose. My bad. So we have 6. Oh, what am I doing? Yeah, 6w squared minus 12w squared is -6w squared. Bring down the -7. We're going to go back to the alley. -6w squared divided by w is -6w. Goes up. Comes down. -6w times w is -6w squared. -6w times -3 is positive 18w. Draw the line and change the signs. Those cancel. I can't combine those. That's a -18w minus 7 comes down. And I have to go back to the alley. -18w divided by w is -18, goes up, comes down. -18 times w is -18w. -18 times -3 is positive 54. When I draw the line, I change the signs, and those cancel, and I get -61. That's my remainder. So remember, in polynomial form, your function equals your divisor times your quotient plus your remainder. So my divisor was w minus 3. My quotient is negative 4w squared minus 6w minus 18 plus, but in my case minus, because it's negative, my remainder. Okay. In fraction form. Okay, use synthetic division to perform each division. To do synthetic, you take what this would be a factor, so as a 0 I'd put negative 3 in the whole. My third degree coefficient, my second degree coefficient, my first degree coefficient, and my constant. This is the zombie apocalypse, remember? So 2 comes out, times negative 3 is negative 6. 6 comes out, times negative 3 is negative 18. Negative 4 comes out, times negative 3 is positive 12, and negative 5 comes out. That's your remainder. This is your quotient. This is your divisor. This is your function. Okay? And remember, to get your variables, you were at a third degree polynomial. You depressed it down to a second degree polynomial. So, to write my answer in fraction form, you say f of x over d of x equals q of x, 2x squared plus 6x minus 4, plus, but in my case it's going to be minus because it's negative, my remainder over my divisor. Okay? That's fraction form. It says use the remainder theorem to find the remainder when f of x is divided by x minus k. Check by using synthetic division. The remainder theorem says if they don't want the quotient, if you have no desire to know what the quotient is and you just want to know what the remainder is, you can find f of k. In this case, if I find f of negative 3, I'd have negative 3 cubed minus 4 times negative 3 squared plus 4. If you type it in a calculator, you'll get negative 59, which means that x plus 3 is not a factor, and it means that x equals negative 3 is not a 0. Okay? Alright, so it says, again, use the factor theorem to determine, no, not again, sorry. Use the factor theorem to determine whether the first polynomial is a factor of the second polynomial. Again, if they didn't, you could do division and decide there, but if they don't want to know what the actual quotient is to decide if it's a factor or not, you just have to decide if you get a remainder of 0 or not. If 0 is the remainder, then it's a factor. If you get anything but 0, then it's not. So if I find f of 2, not negative 2, it would be 2 cubed plus 5 times 2 minus 18. This would be 8 plus 10. That would be 18 minus 18. So my remainder is going to be 0, which means yes, it's a factor. This thing will cross the x-axis at positive 2. Okay? Alright, it says using only algebraic methods, find the cubic function with the given table of values. Check with the grapher. They are giving me, if you have a y coordinate of 0, you have an x-intercept. So they're telling me x equals negative 2, x equals 3, and x equals 4. Which then as factors would be x plus 2, x minus 3, x minus 4. Agreed? So my polynomial function is going to be some leading coefficient, that's the only thing they didn't give me, times each of my factors, x plus 2, x minus 3, x minus 4. I've got to figure out what a is. Well, like I keep saying, we've got too many I don't knows. We don't know y, we don't know x, and we don't know a. All I want is a, which means I've got to come up with some x's and y's. Oh look, they gave me one, an x, and a y that's not a 0, because you need one other point that's not a 0 on it. If I change y to 48, and all of my x's to 0s, and I simplify that, I get a times 2 times negative 3 times negative 4. That gives me Negative 6 times negative 4 is positive 24a. Divide by 24, and a equals 2. So now I can write my function, f of x equals my leading coefficient. That's all I got to change. Everything else stays the same. X equals 2, x minus 3, x minus 4. There you go. Okay, use the rational zeros theorem to write a list of all potential rational zeros, then determine which ones, if any, are zeros. Alright, they're talking about your PQ list. Well, my P has to be factors of the constant, so I need factors of 35. 1, 35, 2, no, 3, no, 4, no, 5 and 7, 6, no, 7 and 5, that's it. Q has to be a factor of the leading coefficient, which is 1, which makes my life easy. The only factors of 1 are 1. So my P over Q list is 1 over 1, 35 over 1, 5 over 1, 7 over 1, which simplifies down to plus or minus 1, plus or minus 35, plus or minus 5, plus or minus 7. Okay? Now, to find the rational zeros, we could just start randomly guessing. Maybe it crosses at 1. I could put 1 in the hole and do my coefficients. 1, 1, negative 37, positive 35, and see. But we use a little old and a little new. Okay, so when I graphed it, I can see that I can see it crosses at negative 7. I can see that it crosses at 1. And I can see that it crosses at 5. So my rational zeros are 1, 5, and negative 7. Again, that's cheating, but I mean, without the graphing calculator, what you would do is if you found one, like this one's obviously going to work, 1 would come out, bring back 1, comes out 2, brings back 2, comes out negative 35, brings back negative 35, 0. That would drop it down to a second degree of a function, and then I could actually just factor that, set it to 0, and solve it. Once you get it down to a first or second degree, you can solve it yourself. You don't need to use technology. This would be x and x. Factors of 35 that make 2 are 7 and 5. C is negative, so only Bully gets the middle. He doesn't. Set them to 0 gives me x equals negative 7 and x equals 5. And those are all rational. And that's all there are, because I can't have more than 3. Alright, use synthetic division to check that the number k is an upper bound for the real zeros of the function f. To be an upper bound, what that means is if you do synthetic division, this line here has to all be positive. If it's all positive, then you found an upper bound. And it's not a 0. What you're seeing is whatever this function does it cross again after 3, or is 3 the upper bound? In other words, it doesn't turn back around and cross over here anymore. Well, we do synthetic division, third degree, second degree, first degree, constant. 4 comes out, brings back 12, comes out 5, brings back 15, comes out 16, brings back 48, comes out 44. They are all positive, so yes, it's an upper bound. And you can see on this graph, nothing happens after there's 3. Okay, I know that it's a third degree. This tail has to point up, so I know it's not coming back down, and that's what's going to happen. Alright, use synthetic division to prove that the number k is an upper bound for the real zeros of function f. Yeah, okay, so it says, does x to the 4th plus 3x cubed plus 90 have any real zeros greater than 5? They're asking you, does this thing cross after 5? And you can tell by the graph it doesn't, but we can do synthetic division. If all of these come out positive, it means that 5 is an upper bound, which means no, there won't be any x-intercepts after that. 4th degree, 3rd degree, 2nd degree, 1st degree, constant. 1 comes out, 5 comes back, 8 comes out, 40, 40, 200, 200, 1,000, 1,090. They're all positive, which means it's an upper bound, which means nothing will happen after 5. Alright, and number 30. Find all of the real zeros of the function, finding exact values wherever possible. Identify each zero as rational or irrational. Alright, we would do a combination of our PQ list and graphing technology. My P has to be a factor of 35, which is 1, 35, 5, 7. My Q has to be a factor of 3, which is 1 and 3. So all my possibilities are 1 over 1, 1 over 3, 35 over 1, 35 over 3, 5 over 1, 5 over 3, 7 over 1, 7 over 3. So plus or minus 1, plus or minus 1/3, plus or minus 35, plus or minus 35 thirds, plus or minus 5, plus or minus 5 thirds, plus or minus 7, plus or minus 7 thirds. So I don't want to just start randomly guessing where these cross at, so I'm going to use a little bit of technology. I can see that, well, these two are going to be irrational. This is a repeater. This one is a repeater. If I type in 1.66666666666 all the way to the end of the screen where it starts going on the next line, just 666, don't ever type the 7 and then hit math, enter, it will turn it into 5/3. This is actually 5/3. So out of all of these, the only rational zero is 5/3. Okay? So now to get the other two, because, I mean, I know you can tell here, but I'm going a little bit backwards. To get the other two, I'm going to put 5/3 in the whole and divide by it. 3rd degree, 2nd degree, 1st degree, constant. And don't panic on these fractions. All else fails, you have a calculator. 3 comes out, 5/3 times 3. The 3's cancel is 5. Negative 5 plus 5 is 0. 0 times 5/3 is 0. Negative 21 comes out. 5/3 times negative 21. 3 goes into negative 21 7 times. That's negative 35, which is 0. Which it better be, or my graph's lying to me. So that drops it from a 3rd degree down to a 1st degree. So I have 3x squared minus 21. Once it's down to a 1st or 2nd degree, set it to 0 and solve it. You can do whatever you want here, but I'm going to use square root property because there's no 1st degree x. So I'm just going to isolate and kill. So I'm going to add 21. That gives me 3x squared equals 21. Divide by 3. X squared equals 7. Square root. And x equals plus or minus the square root of 7. And you can see I typed them in and got decimal equivalents. Oh, look, I did type that one in for you. See how I typed 1.666666 and then I did math enter, that gave me the 5/3. Okay, repeaters are rational. It's the non-repeaters that never end and never repeat. Those are your square root ones. What did I do? I don't know what I did, people. Sorry. Anyway. There we go. Alright, so those are my irrational roots then. And we are done. So happy reviewing, and I will see you next time.